Alright guys, welcome back. I'm your friend InSaxo. Today we're going to do another experiment about the artificial intelligence. We're going to use machine learning to play the Mario. It's something like this. As you could say, this is a game called Mario. I assume you played this in your childhood. Today we're going to do it, or we are going to play it with the AI technology. And here it is a report from someone. He's using the PyTorch, and according to his introduction, that he did very well on this kind of job. So let's just get into it and say how well it is. For this repository, the author provided us a way to evaluate the results of that model, which is the test.py. We just had to run that file and it will start to do that job. As you could say, for now, I didn't do anything. The AI model is trying to play the Mario itself. And as you could say, it's pretty good along the way. Although it's just about the level 1, but it's pretty good compared to what I did a few years ago. Well, and interesting about this is that when I get into his model.py, when I look at those code, the convolutional layer, the linear layer, the whatever, what I saw is that it's a TensorFlow model. But then I go to his repository, I say that, oh, it's using the PyTorch. So actually they are the similar in my eyes. They are the same. Okay. So our mission today is to convert all those code from his repository into our own repository. Here is my repository. I created this a few years ago. It only got two simple files, the main.py file and the model.py file. I could show you how it does. For now, all I have to do is to run this model, and here you say this is my model. It's pretty slow and it may get some problem. Okay, here we go, hit that. So the model doesn't work at all in my opinion. That's why we had to do some changes about it. But before I do anything, I'd love to just set up the environment first, because that's the basic part of everything. So let me create it. Conda create len with Mario and with the Python equal to 3.9. Right, after that we activate that virtual environment. Here we go, now we got our Conda environment, set it up. The next thing we are going to do is to install the poetry. I don't know if it's working or not. If it's not working, I'll just stop using. Okay, then I'm gonna say poetry initiate with everything as the defaulted one. And then we say yes to generate that file. After that, let me say if we wanna install something. Since we wanted to play the Mario, we must have the Mario environment set it up. So that's why we need this package. Let me do this. Poetry aid, this package. If you are using the M1 Macbook, you'll get this error. It says that the C compiler does not support merge equal to native. That's okay, since I already found a solution for that, so let's go and try to solve that problem. Here we go. It cannot install the NESPY because we are using the ME Macbook. What we need to do is to first clone this repository, and I already did that before. Then we're going to go to the setup.py file. From there, we're going to do some changes. For example, we're gonna replace this block of code into this block of code. After we did that replacements, we can start to use the pipe install dot to do the installation. And when it's done, we can go back and try this again. Okay, for now it's working. By the way, if you want the VS Code to use your virtual environment that you just created, you can head into the Mario bin that Py's right in here. So now, as you could say, we only need to install one more package, which is a TensorFlow. Then we would finish the job. The problem is how. According to the Apple's documents, if we want to use a TensorFlow at the M1 MSA, what we need to do is to use a conda install Apple and TensorFlow dependencies equal to 2.6. So let me do that. And after it, we need to install the TensorFlow MACOS. Oh, sorry about that. We didn't get into that environment. So let me do that again. Okay, then we install the TensorFlow MACOS. After the installation, let me go ahead and install the TensorFlow Metal. This package would allow the software to use a MAC GPU. Okay, after a restart of the VS Code, now we could say that we got all those dependencies enabled. Great. The model itself is quite simple according to this code. So let me just transfer that first. Yeah, according to this, we get 4 layers of convolutional stuff. 1, 2, 3, 4. We need 4 of them. And for each layer, let's say for the inputs, we got the number of inputs. It's undefined for now. Well. How about we give it a parameter here, the input and the action. The first layer will take that the number of inputs and 32, 3, the input path, the input shape. I'm gonna have a look at the PyTorch function definition. The first parameter is the input channels. The second one is output channels. The third one is the kernel size. Alright, then let's go to the TensorFlow's function definition. For the TensorFlow, the first one is the filters. The second one is the kernel size. Filters, integer, the dimensionality of the output space. So for the TensorFlow, the first parameter is the output shape, but for the PyTorch, the second one is output shape. So the first one here should be 32, and the second one should be the kernel size, which is 3 right in here, and the input shape would be just equal to the number of inputs, something like that. Let me say, here we go. Oh, wait a minute, we shouldn't do this. Let me do some modification here. We'd love to rezone or save the old code. That's why I'm gonna create a new folder and then put all those old code into that. Okay, now before you do anything, let me just save those dependencies about the conda environment. Here we go. Now we got an environment file in here. Great. Then let's go on. Input, output, and the kernel size. For this one, this would be the output kernel size. What's the second one? Third one is the streets. Streets equal to 2. About the padding. For the PyTorch, if the padding equal to 0, it means valid. Valid means no padding. For the TensorFlow, the padding is defaulted to be valid, so we can just leave it there without any problem. Then for the input shape, that's something that matters. We're gonna try to give it as inputs, number inputs. Then we will have the activation layer. That's okay. How about the second one? The second one, 32, 32, 3, and everything stays the same. Alright, let me just do a copy. The input is 32. The output is 32. The kernel equal to 3. The street equal to 2. Wait a minute. If the padding equal to 1, that means it has the same value. So we're gonna try to put every padding. We're gonna put the padding equal to the same to every TensorFlow line of code. Alright. Then we're gonna repeat this 2 line of code for 4 times. After that, we will have a linear layer. Let me have a look at the PyTorch linear layer. It has 2 parameters, the input features and the output features. Basically, that's the size of the input and the output. Let me have a look at the TensorFlow side. Okay, interesting. It seems like the TensorFlow side doesn't have any definition for you to define the output size. Is that true? I don't know. Okay, according to this post, it says that the TensorFlow dense layer is equal to the pytorch linear layer if we set the activation equal to none. So let me do that. For the TensorFlow dense layer, what you could do is to specify the output size. You couldn't specify the input size for this case. So the output size would be 512. Now I know why people love to use the pytorch, because it has a fine control over the input and the output. You have to always calculate out the input size and the output size to be able to work on with that. Otherwise, you couldn't. But with the TensorFlow, you can basically mess up with it. You don't have to know those details. You just put all those code together to form an application. Well, can anyone tell me what is the meaning of this x.view? Is this a function? Returns a new tensor with the same data as the self tensor but of a different shape. The returned tensor shares the same data and must have the same number of elements, but may have a different size. For a tensor to be viewed, the new view size must be compatible with its original size and street. Okay, I guess I know what it does here. Let me just have a look at the pytorch. TensorFlow flatten alternative in pytorch. Okay, it seems like that the pytorch indeed has the, let's say, has the flatten. I guess that's how it is called. Flatten. It has a flatten function. Why the other love to use this weird function? That makes sense. So for the TensorFlow side, we'll just use the flatten function. Okay. After that, there has something special happened. Instead of returning one result, the other actually returned two values from that single function. The first one is the critic linear, and the second one is the actor linear, which will output the actions. So, well, let me say if it's gonna work or not. For our case, here I'm using the tf.keras layer dense with the number of actions, which is correct. It will output that number of actions. Oh, maybe we should use this number here. And the activation should be equal to no, I guess. Then it also have another layer which will output just one stuff. They call it the critical linear. Quite weird. So far, we just constructed a simple neural network. It's a linear one. It may not fit the needs. It may not meet the needs, but we could just take it as an experiment. Welcome back. If you look carefully about those codes that he is using, you start to think, well, why he makes sense so complicated? Yeah, but we could still find some logic here. For example, here he's using the model to take the input, which is the state, then output two values, the logics and the value. For each value, he's using it to calculate out the actor loss, which uses the logics, and then the critical loss, he's using the value, and in the end, he's using the total loss. Yeah, man, that's just too complicated. So let's go back to our own model, and from there we will try to create it by our own. And in this case, if we do it by our own, we could simplify all those things away. And this is my code. It's pretty simple. Okay, let's have a look at this code. First, we have a path to save the model, and we say if it doesn't exist, we will node that model. Oh, sorry, if it exists, we will node that model. Otherwise, we'll generate a new one. And then we got the identities, which is those actions that we can choose. We put it into a vector. Then we have a forever loop. For every 5,000 training, we save that model. If the character is dead, then we will reset that environment. There has 1 of 10's possibility that we will take a written action. Otherwise, we will try to predict the next action by using our model. And for each action, if it's been taken, we could get a new state, the reward, if that character is dead or not, and some other informations. Then we will say the last state equal to the state. If the reward is greater than 0, we would train that model by taking that action we just taken. It will go on and on. When I look at the code of that order, I start to think that maybe we should do some pre-processing for the images that we got for each frame. I don't know, let me have a look. Oh, here we go. It's indeed did a pre-processing for that. So we are going to do that also. I just create a new PY file. From there, I put this function in. Then we need to install the OpenCV, which is this package. Okay, it's done. So for each state, we are going to use the process spring to handle. Okay, I guess the most critical part about the Python is that you'll never know what you will get unless you run it. I feel the same for now since I don't know what would happen. So I just run it. We got an error. NumPy core build array failed to import. Well, in other words, he is failed to node what? Node this function. Damn it. This solution. It says that all we have to do is to reinstall the NumPy. Then that would solve that problem. So poetry upgrade NumPy or update NumPy. They will do the same thing. Let me just try to run it again. Again, we got this weird error. How about we use pipe install u lamp? Nothing changes. Okay, maybe we should try to install another version of OpenCV. So poetry 8 OpenCV Python equal to this. Well, it's not working. Alright, then let's install the NumPy by the conda. After that, let me try to run that file again. Again, we got this weird error. Yeah, I was thinking if we could not use the NumPy, what could we do? This is ridiculous. Okay, let me do this. Pipe uninstall NumPy. Then poetry uninstall NumPy. In the end, we say conda install NumPy. Let me try to do that again. Alright, we got a new error. Module NumPy has no attribute. Float 32. Okay, conda uninstall NumPy. If we do so, we'll affect a lot of files. So that's not an option. Yeah, the problem here is that, yeah, I don't know what's the problem here. It seems to be ridiculous. Okay, let me just do a restore for this. Let's see if we can save it. Come on, we still got the error. Okay, after I have using the poetry aid NumPy, this command, then everything goes to right again, which is quite weird. This is a Python. We will often have some dependencies errors. Okay, for this time, the error we got is we do not have the parameter, number of inputs, and the number of actions. we can give it those two things. It could be as simple as, I don't know, maybe it is inwait.actionspace.end. That's the first one. Oh, sorry, that's the second. And the first one, it is the number of inputs. It's hard to say. Let me say it should be 84, 84, and 1. That should be the input. Or maybe I was wrong. Should be this 184, 84. Okay, now let me just run this code. We got another error. PYGLET symbol not found. How about we do this installation? It should work. So poetry aid this. So poetry aid GIT response. So that should be poetry aid with the len of that response. PYGLET and the GIT. After that, it's the URL. Okay, let me try this. Oh, we still got an error. Okay, let's forget about it. Just do this. Right, after the installation, let me try it out. First time it's working, but pretty slow. I don't know why. Okay, if we do this, it will probably take 1,000 years. So let me do some modification about it. For now, we are going to use TensorFlow Hub. Right, for this case, I'll just use a feature vector extractor to extract out those features so that we can use later. Then we will need to install the TensorFlow Hub. We can even use it as the first layer, so just do this. I just use it as the first layer. Trainable equal to false. Inputs would be just equal to the number of inputs. Okay, now everything is set up. We are ready to go. Right, if we want to use that as a feature extractor, we will not be able to use the convolutional 2D anymore. So we are going to do something like this. And we don't even have to use a flatten function because it already does that for us. Okay, so let me try it again. Right, for this case, we do not need the pre-process, which is this line of code. I'll just comment it out. This is what we get, which is quite weird. The character doesn't want to move at all. Okay, start to move, but it fails. Since it made the enemy. Yeah, I'll leave it there. For now, we definitely do not have the inception problem. I mean, the robots or the software will definitely receive the correct information. If this will not work, there definitely has one problem, which is the strategy that we use. For now, we are using the simplest way, which is whenever the reward is greater than 0, we do this. This will definitely not enough, so I don't know, I'll just leave it there for a few hours, and after that we will go back and try to improve the policy or the strategy for our software. Well, no time to wait for a few hours. I just do not think that it will work since it will start up before the building. He cannot jump over it since he don't know that if he jumps higher than before, it would help him to get over that obstacle. He doesn't know that, so I just do some modification about the code. Yeah, for this case, what I did is whenever the y position is greater than the last one, then we will give it a trim. For now, it's working slightly better since he knows that he needs to jump higher to cross those obstacles. Right, it's been a while, so according to the current status, I do not think that this character has any intelligence here. We may have to do some changes about it. For example, this Mario doesn't know if he take an action, what's gonna come in the next. He doesn't know that. Since we will train it only when the reward is greater than 0. What if the result is less than 0? He should get punished, but in our code, he doesn't receive anything. That's the problem. So if we want to modify this code, I guess I'll just add another neural network. We'll add another model. And in that model, it will try to take the previous action and previous state as the input, output the future reward as the output, and we will use that output. For example, whenever the Mario has to take an action, we give another model all those options to say which action would get better reward. Then we will take that action. It will definitely better than this one. Hey guys, welcome back. Here, as you can see, it's a paper about the reinforcement learning. Here he got a table. It says that if we use the A3C method, the training time would be just 1 day on the CPU. And for now, we have a GPU, so if we use this method, we probably could just use a few hours to train that model, which is really helpful. So this is a method that we will stack on to. Alright guys, it seems like for the TensorFlow part, for the party of the TensorFlow, they are probably broken because, as you say, those code that they have, those examples that they have, they are still using the old grammar. And when they updated those scripts 2 years ago, it's too old. But if you have a look at those other stuff, for example, the PyTorch side, you will start to think that, well, for now the PyTorch is more popular than the TensorFlow. So how about we just use PyTorch to do the experiments today? Because I don't really want to waste my time on this. That makes sense. Alright, this is my version for now. Clearly, I don't know how well. Oh, it is bad. So forget about it. I'll just stop it and we'll try something else. Instead of the TensorFlow, we'll try the PyTorch. So let's go on. The conda create lamp equal to Mario. The Python version 3.9. Remove the existing environment for sure. We say conda activates Mario. Install the poetry. After that, we go to the PyTorch. I guess we could use conda to do all those jobs. So let me just install it. It cannot find the torch audio, so leave the video there. We do not want to install that. Okay. After the installation, let me just go back to this project. We will try to reproduce the repository this author does. So we'll try to copy his file into our own repository. First, it's the test.py. Alright, we need to install a few packages. So poetry initialize. Then add the GYM Super Mario Bros. And go to our local nes.py repository. From there, we will try to install this packaging. After that, we try to install that again. It's done. Okay, so what's next? It needs this RC folder. So let's go to there. We'll copy the whole folder into our repository. Okay. And we will also need the trained model. After that, let me just run the test.py file. No model lambda CV2. Alright. So poetry 8 this packaging. Let me try it again. Broken pipe. Why we get this? Inside of the envelopment, we got this error. So this is broken. It's probably because we do not have the FFmpg installed, so well, we're just 81. Okay, after that everything should be fine. We still got that error. Alright, so what can we do? I just simply remove those lines that related to the record. Okay, let me do it again. PYGLET symbol not found. That's another stupid error that related to this, not this. Related to this, we have to install this version of code. Remember, this is Python. If you're using some other packages like the Rust or the Golang, you probably will not meet this problem. But it seems like nobody used Rust or Golang to do the machine learning. Nobody do that. This is interesting. So anyway, let me forget about that and try to do this. Here we go. We could run the test.py file without any problem. It's still working as we expected, and it's working pretty good. I don't know why he's got it so good. Anyway, we are going to repeat his process and try to create the whole stuff with our own idea. Then we're going to copy the trim.py file. Before we do anything, I'd just like to format his source code for a little bit because the old one sucked. I don't know why he's writing his code. Nobody could understand what he was trying to do unless we do a format. If you take a look at his model, here you would say it's working pretty good at the first level, but whenever this character gets into the second level, for example, right now you will say it will start to lose control. So that's the limitation of his model. What we are going to do is to try to fix it. Okay, let me just do a training. Handle is closed. Why? Okay, it's quite interesting. I don't know why. For the wrong function, at the beginning, what it does is to close that. How stupid it can be. If you close it, then it will not receive anything. Why he would do that? Well, handle is closed again. What is this error? Why? Does anyone meet the same error as I did? Let's go to the... It doesn't have any issues. Here we go. Here we got a bunch of issues. Money. Oh, those guys says use Linux to deal it. Does that mean that we could not run this code on the MSA? So stupid. Why? Why? Alright guys, finally I managed to make it work. What I did is in here, the torch mute processing. There I set the start method to fork with a force equal to true so that it will not spawn that process. You know, this is a bug for the Python in the M1 Macbook because the mute processing will by default in the M1 Macbook to choose the spawn method, which would cause errors. So that's why we have to force set it to fork method. Okay, that matter. Let's just run it. Oh, wait a minute. We probably wanna do some changes. I don't know. Let's just run it again. For now, I could feel that my computer is running heavily. Well, you could say we got 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 9 Python scripts running behind of this. They're doing the same thing. I mean, they are doing the training at the same time. I guess I have no idea about that. Oh, it start working. I mean, start to, I don't know. It still seems to be stupid. I just stop it because it doesn't work like I expected it would be. Alright, let me do it again. Alright, I couldn't stand this anymore. It seems to be quite stupid. Why it takes so long to just bypass the first enemy? I guess I'll just give it some power to say more stuff. So let's go and see if we can use P1 merge or the transformer. I have no idea about that. Transformer. For this case, it's about the computer version. It should be image classification or anything would be fine. I don't really care about it. If we could use this transformer, we could get the feature of an image. Then we need to feed it to our model. How can we do that? Let's go to our model. Here, it will take the number of input. I don't know what kind of. Yeah, let's do a check about the reference. Here we go. This is the first one, and inside of the tree, we also have one environments, number states. Have a look for this one. Come on, okay. Number states. So this is the input that we will have. So we have nothing to worry about anymore. Wait. Do it. Here we go. We're gonna try to import that model. Then we'll use it to help us to do the thing initialize weight. It's probably inside of this. X equal to that self.feature extractor. The image would be just equal to X. I have no idea about that. Okay, now we need to install the transformer. Well, for this case, we got this error because probably somewhere we did wrong. It's related to the process frame. So we'll do nothing here. So I just return the frame. Yes. For this case, we got 11256, which is still wrong. Alright, after a long time of trying, finally I decided to reverse all those changes because I do not think modify his file is too. So let me do a reverse. Although we couldn't modify his file, we could still have a look at the inputs. I mean the forward X. What kind of value he's giving to the model? Oh, sorry, it should be turnout X shape. Okay, here we go. Sometimes it's 8 for 8484. Sometimes it's 1 for 8484. It's kind of weird. Why? I don't know. Okay, for this time, since we are not using the feature extractor, to be honest, the len of feature extractor here is kind of misleading. For this model or for this, let's say, object, it will not actually extract any feature from that image. What it does is to convert that image into a vector. That's the functionality of that object. So basically, we do not need that. Actually, the real stuff that we need for this case is a model. It's the classification model itself, right in here. For this case, it says that the image size doesn't match the model. This is correct. So we need to do a resize, or yeah, we need to do a resize for that image. Okay, here seems to have a function. Maybe we could use that to do the resize. For this case, we'll just convert it into 224. Let me try it out. We should put it before that function. For this time, we probably got it correct. Alright, so let me just do this. Giving groups 1 weights of size whatever, expected input of that to have 3 channels, but it got 4 channels instead. Okay. So instead of doing the resize, we have to do another step, which is to get rid of the RGBA, the A alpha channel. Let me see if this is working. X equal to that. Okay. It didn't work for some reason. Okay, I did some modification. 1, 2, 3. Yeah, that's correct. Let me just try it out. For this case, we got another error. It says that sequence classifier output object has no attribute view. Okay, so after all, at least we got the output object, even though I don't know what's inside of that. We could print it out. This is the basic thing that we could do with Python. You know, in a lot of cases, we just don't know what the output might be. Okay, hidden states logics. We do not have the hidden states. I basically do not know what kind of result that we should get from that. This is what it returns. Hidden state, it's an optional one. Return when the output equal to hidden state equal to true is passed. We need the hidden states probably, or we need the last hidden state. Let me try it out and see if we can get that out. Oops, we got an error. Should be right in here. Alright, let me do it again. It doesn't have the last hidden state, so we'll just get the hidden state instead. If we want to get that, we have to specify output hidden states equal to true when we call that model. And also, probably we have to specify the output equal to tn, which is python. Okay, now let me just try it again. Got an unexpected argument to return tensors. Oh, was that really true? Yeah, I don't care. Let me just try it again. Alright, now we could get the hidden states, which is pretty cool. For now, since we got the hidden state, and we could let it go on. Oh, sorry. We're gonna do something like this. X equal to X hidden state. We still got an error. It says that tuple object has no attribute view. So we're gonna have 1 out from that data. We get another error. It says that matter 1 and matter 2 shapes cannot be multiplied. Well, that was unexpected. Where that error comes from? We probably had to do a flatten for that thing. Okay, so let me do this. pytorch flatten. This is function for sure. So x would be equal to tensor pytorch. Where are you? Or f? No, let me do this. And we got a flatten layer. So I'm going to use it. Flatten equal to that. Be just equal to flatten x. Then everything would be done. Let me try it again. Okay, we still got this weird error. I have no idea about this. So let me just print out the shape of that x. Well, even if we did the flatten, it still seems to be incorrect. For sometimes we get the 1, for other times we get the 8. I do not sure about it. So I'm going to go to the model. This is the original model. I'm going to print out the x and pick the x. So now I will just say, let me just do a test. Alright, for this one, it will just print out one single tensor. But what if we do the training? If we want to do that, as I said before, we have to add something to here. Environment set start method equal to 4. Yeah, this time it's output 2 of them and no errors. So this is kind of weird. Why? In our case, we would get that error. Let me have a look at this. Oh, we got that error because we have 2 different shapes. He doesn't give us an error because he's using the same shape but with different batch size. Okay, let me go back to the model. Here we need to do some changes, otherwise it won't work, since we got 2 different shapes. No, actually we got the same shape here, but why we still get that error? That makes sense. Let me just go to the next layer, or how about we do not do the flatten and see what we would get. Yeah, it still have the same shape. So that shouldn't be the problem. The problem may come from the next level. Mat1 and Mat2 shapes cannot be multiplied. Okay, so find out where's the problem. We'd better do it one by one. For example, x equal to that, then we print out the x, so that we could know if it's that line caused the problem. No, it's not that line. That line of code, what it does is just the same like the flatten function. Yeah, as I expected. Alright, so it's the problem of the next line. The next line is a linear function, which is a dense layer. Why we get that error? Okay, I got it. So if you look at this code carefully, you will start to notice that the first one is the input, the previous layer's output, and the second one is the current layer's input, and and for this number, they are not matched. We need to make it the same, so that they could do the multiplication. They could pass the values around. So this is the logic. In this case, we are going to change this line of code. Okay, it seems like if you do the machine learning with the pytorch a lot, you would generally understand the core part of the machine learning, of the neural network, of the matrix. But if you are using the TensorFlow all the way, you will never know what's going on there. Okay, so that's why the TensorFlow team is generally start to giving up the TensorFlow. Why I know that? Because if you go to the Hugging Face, if you go to his model, you would start to notice another package called GAX. This guy. This is a new framework that Google is trying to promote. Alright, let's forget about that. And for now, we can go on with the new neural network we have. Okay, for this case, it's working with the pre-trained version model, which is a Google weight, base, patch, whatever. By using this model, we could have a better inception from the image or from the environment. The drawback for this method is that it would take more memory and computing resource because it's using a pretty big pre-trained model. We can handle this problem. We could make it better by using a smaller pre-trained model. And for this simple game, I guess it's not necessary to use such a big model. So let me just drop it and try to find another one that has a smaller size model. Okay, so let me go to here and go to the image classification. Search for letter. Tiny, no. Mobile, never mind. Well, I guess the base is already the smallest one. With small DAs. Probably this will also work. I don't know. Let's try to do more. Fast AI, no. With small patch, no guarantee that will work. Small. Oh, here we go. We got a tiny mobile net or whatever. Alright. It's done working. I'm trying to find another one. Object detection might be good. Okay, I give up. I just use the image classification version. Here we have a lot of stuff like that. I guess we're using the base, which is the correct choice. We should use the base. So, okay. If that's the case, I'll just remove the trained model, which means we will start the training from zero. Okay. Let me just head to the start. But I just pause this video. When we back, we will see the results. Hey guys, I just start to think that according to current speed, we would never be able to finish this project. So let me think a way to bypass this. It's too embarrassing. Well, it seems like we could. The PyTorch has provided us a lot of pre-trained model. For example, I think the Mobile Light V3 would be fine for this case. And all we have to do is to import that model. So for this case, we will not use the transformer, even though he's pretty good for the natural language processing. But for now, we will not use it. So let me print out the output from that Mobile Light model. Well, we get an error. Cannot import len that from PIL. Quite stupid. So poetry aid this model. After that, we try this again. We still got that stupid error. What can we do? Can we specify the version of that? Okay, after the installation of a specific version, let me try it again. Alright, it says that module has no attribute MobileNet V3 small. Then how about we use V2? That module has no attribute MobileNet V2. This is weird. If it doesn't have that, let me just say what kind of model you have. Just print it out. Well, for those models, they may be too large for our case. I have no idea. Let me just try to get one. VGG11, the required minimal input size of that is 24. It's 34 times 34. This will meet our needs, and it will decrease the size of our model by a lot. But let me have a look at others. This is a very deep convolutional network. We don't need that deep, we just need a few of them. So VGG11 might be just enough for our case. Okay, Then I'll use that. Wait a minute. How about the VGG itself? Say VGG 11. Yeah, for this case, what we got is just a tensor. I don't know the shape yet, so let me just print out the shape. 1000. That might be okay for a case. So let me use that. Wait a minute. If we use the VGG, then we do not have to use an interpolator or something. We do not have to rescale that image. In this case, it's definitely have a better performance. Yeah, I could say it from my eye. And besides of that, if we got 3 channel of that input, why we have to convert all those stuff to gray? That makes sense. Why we do that? So we don't do that, and we will do the resize, but we do not divide it by 255. Okay, let me try it out. For this case, we got an error. Okay, look at this. Why we got this weird inputs? Alright, so before we pass it to the VGG, we need to do a resize for it. It needs to give us an idea that we have a wrong inputs all the time. So what we need to do is to search for pytorch, reshape, not reshape the layer, but reshape the tensor. Here comes an idea. I get an idea. The first one should be x dash shape 0 times x shape 1. And for the following, it should be 84 times 84 and 3. This might work. Let me just try it out. Yeah, it's working. So let's go on. We give it to the VGG model, and it will do the rest. Okay, it expected the input to have 3 channels, but got 84 channels instead. Why? Right, I guess I understand where the problem is. We are going to go to the environments. From there, we indeed have to do a conversation. Let me do this. We are going to print out the frame that shape before the grid and after the grid. And we exact that program. Okay, so before the grid, it's something like that, and after the grid, it's not. Well, why do we get this? For this case, we have to separate the RGB channel out into 3 vectors. After we separated it out, we're gonna construct a new RGB file. Alright, so we go to the model. Before we do anything, I'd love to just print out the X shape. Okay, let's forget about that and try to do the following. That'll be 3, 84, 84. By I don't know this, so I just give it a -1 value. I hope it's working. It says that that shape is invalid for the input of that size. Was that true? Let me just do a dy. We get the Python, right? This value divided by 84 divided by 84 divided by 3. We get a float number, which is not correct. Oh, I got it. So my bad. First, we need to do a resize for it. That's a priority. Then we do the following. Everything should, yeah, as I expected. Now all I have to do is waiting for things to getting better. So I'll just pause this video. Alright guys, welcome back. It's been a while, but it still seems to be bad for now. the model we have doesn't work at all. So let me see if I can do something else. Here we go. If we use the original layers for that model, will it be better or not? I don't know. Here we get an error. It says expected input of that have 4 channels, but I got 12 channels instead. Alright, so let me just undo all those changes we made before. Okay, it seems like if we use the original setting for this model, it can be quite, it will have a super quick speed, which is good. So let it be this. We'll come back to check it later. Okay, I'm pretty sure his version will definitely better than my version, because sometimes this character would go far away than what my version does, because the training for this model is way quick than my version. Here, it's just an example of how well it does. As you could say, it can indeed go into it can indeed run a long distance. It's definitely better than my version according to this view. Yeah, the only problem for this method is that it really takes a while to train, probably 1 or 2 hours. 2 hours, I guess. Well, if you compare it with other method before, just a few years ago, if they want to train a model that could play the Mario, it would take at least 30 days. That's a lot of time. But for now, with my M1 Macbook, it only requires a few hours. So yeah, it's an improvement. But again, I do not think that it has any intelligence out there, because if it has, this game will only cost him probably a few minutes, then he will know how to play the game. That's how human does. But for him, what he spent is a few hours. Well, speak of my computer. The good part about the M1 Macbook is that the GPU and the CPU uses the same memory. So if you have a 32 gigabytes memory, then it also means that you have a GPU that have 32 gigabytes memory. They share the same memory. So at least we could know if we want to train a reinforcement agent to play games, the first thing we need to do is to try to decrease the data complexity so that the agent could train it in a faster speed. Here, what he does is to convert the color from the RGB color space into the gray space, which tremendously decreases the complexity of that data. And then what he did is to do a resize. This would also help for the training. According to this pre-trained model on the login phase, it seems like people love to scale their image into 224 times 224 because it will decrease the computing complexity while also achieve the task. Well, for this time, what we are using is a method called the AAC method, I guess. I have no idea about that, so I'm going to do a search about it. Here we go. If we go to the reinforcement and learning folder, we will say there get a bunch of, not AAC, but PPO. I have no idea about that. It's called the Proximal Policy Optimization Model. What is that? Here, the OpenAI says they published a new algorithm called Proximal Policy Optimization, which performs comparably or better than the state-of-the-art approaches while being much simpler to implement and tone. Well, it seems like for this demo video, what the character trying to do is to approaching the ball. Let's have a look at this article. Policy gradient methods are fundamental to recent breakthroughs in using deep neural networks for control, from video games to 3D locomotion. What is to go? But getting good results via policy gradient methods is challenging because they are so sensitive to the choice of step size, too small, and progress is hopelessly slow, too large, and the signal is overwhelmed by the noise, or one might say catastrophic drops in performance. They also often have very poor sample efficiency, taking millions of time steps to learn simple tasks. Yeah, that's true. Researchers have sought to eliminate these flows with approaches like TRPO and ACER by constraining or otherwise optimizing the size of a policy update. These methods have their own trade-offs. ACER is far more complicated than PPO, requiring the addition of code for off-policy corrections and a replay buffer, while only doing marginally better than PPO. On the A-story benchmark, that's a comparison. Let me just read this. PPO. With supervised learning, we can easily implement the cost function, run gradient descent on it, and be very confident that we will get excellent results with relatively little hyperparameter tuning. The road to success in reinforcement learning isn't as obvious. The algorithms have many moving parts that are hard to debug, and they require substantial effort in turning in order to get good results. But as humans, we learn things without the turning. We basically could learn any stuff from scratch if we want. PPO strikes a balance between ease of implementation, sample complexity, and ease of turning, trying to compute and update at each step that minimizes the cost function while ensuring the deviation from the previous policy is relatively small. We have previously detailed a variant of PPO that uses an adaptive DL penalty to control the change of the policy at each iteration. The new variant uses a narrow objective function not typically found in other algorithms. So here we go. This is another mathematics formula. Does it hard to understand? Yes, if I do not tell you the following explanation, then it's hard to understand. So for this symbol, I just forgot about how to read that symbol. But I think we should. But it's just a symbol, it can be anything. Data, alright. The data is the policy parameter here. We input this function a policy parameter. And what is this? This symbol, ET, denotes the empirical expectation over timestamps. So this is a historical experience, which is some data that accumulated over the time. Then for this one, RT, what is that? It's the ratio of the probability under the new and old policies respectively. Okay, it's just the ratio, or in other words, it might be just a constant. It defines how much the new experiments or new policy will affect the old policy. I guess that's the explanation. I don't know. And for this one, AT is the estimated advantage at time t. How do they call its estimated advantage at time t? It's probably the reward at the time t, or the predicted reward. I don't know. For this one, this is another symbol, epsilon. The epsilon is a hyperparameter, usually 0.1 and 0.2. Okay, so that's a constant and a hyperparameter. We don't care about that. It's just a constant. This objective implements a way to do a trust region update, which is compatible with stochastical gradient descent, and simplifies the algorithm by removing the key error penalty and the need to make adaptive updates in tests. This algorithm has displayed the best performance on continuous control tasks and almost matches the ACER's performance at, this is an online game, I guess, despite being far simpler to implement. So it is said that we could use this method to perform some continuous control tasks. The continuous control task, what it says is just some game like this one. You have to continuously control the Mario to be able to get into the endpoint. Yes, for now, the Mario seems to be working pretty good. Okay, well, for this video, what it says is that it can be also used to teach the robots how can he work or how to do the working. Well, it's kind of ridiculous. Why those people do not use human data as a labeled data to teach the robots to work? They should try that, because that's how human works. And also, I guess for the reinforcement learning algorithm, in this case, what the best suitable task for him is to prevent the robot to falling. Okay, it seems like our Mario started getting to the endpoints somehow. We will get in there. Maybe it will just take another hour. Yeah, here we go. Okay, let's just leave it there. While he's in the training, let me just read more PPO method so that we could understand, or we could understand what's going on there, even though we didn't implement that code by ourselves. This is not a new method anymore. So this is an old one, I guess. Okay. It seems like the Keras library, they have an example about this. So let me have a brief reading for this. PPO, proximal policy optimization, is a policy gradient method and can be used for environments with either discrete or continuous action spaces. It trains a stochastic policy in an unpolicy way. Also, it utilizes the actor-critic method. The actor maps the observation to an action, and the critic gives an expectation of the rewards of the agent for the observation given. Firstly, it collects a set of trajectories for each epoch by sampling from the latest version of the stochastic policy. Then the rewards to go and the advantage estimates are computed in order to update the policy and fit the value function. The policy is updated via a stochastic gradient ascent optimizer, while the value function is fitted via some gradient descent algorithm. this producer is applied for many apples until the environment is solved. So for the algorithm, it can be as simple as a single image. Well, I didn't know that it indeed implemented the buffer class. Whenever a model has any connection with a buffer, it can get complicated. Well, but if you think about the stone, it's nothing but a list of observation, a list of action, a list of reward, a list of value, a list of this one, and for somehow he's using a word called pointer to indicate that this variable is an index variable. Yeah, to be honest, I do not know why people want to put the tf function before a function. Let me just do a search for that. This decorator compiles a function into a callable TensorFlow graph. This one will construct a TF types experimental general function that executes a TensorFlow graph created by whatever. Now, just think it as a pytorch function. It's just a function. I don't care about it. Well, here we go. It again uses the tf.gradient type as type. Well, sometimes I think the tf.exponential something, or let's say, yeah, I think this is kind of overwhelming. Sometimes people would more like to use the operator like this one to do the operation. With the pytorch, you hardly say this keyword. You know, even though I use the with the open a lot in Python, but I have no idea why we had to use. I don't know why we had to use the with keyword in Python. Why people want to use with statement in Python is used in exception handling to make the code cleaner and much more readable. With it simplifies the management of common resources like file strings. It cleans up when the code that uses it finishes running. Even if exceptions are assumed, it provides syntactic sugar for trying felony blocks. Okay, so it will release the resource no matter an exception happen or not. Well, if we assume that the GPU is a resource, then yeah, if we get an exception, we should release it no matter how. But I still think that this is kind of stupid to do that. So this is a Python's version. We got all those code, and to be honest, even though we do not know shit about those things, we can still run it and modify it properly. Let's have a look at the pytorch. Despite of the training, let's have a look at the test. Okay, at the beginning we got a bunch of parameters. Then we got the chain, and we got this agent. Agent select an action, the environment take that action. We get the new state, and then we give that new state to our agent to let it to choose a new action. This is a load. Then if we go to the train.py, this can be a little bit hard to understand. But maybe it's not that hard since he's already did a abstraction. He made an abstraction layer here. Let's say at the beginning we do a reset for the environment. Let me just zoom up it for a little bit. We do a reset to get the state of the current environment. Then the current reward equal to 0. Then we start the training. At the first loop, we let the agent to select a state, to select an action. Then then the environment take that action. We get a new state, the reward, and we add that reward to a list, which is a buffer, which is a stone. Whatever you call it, it's just a list. Then we add that down to that buffer. The time step would be added by 1. The reward has to be added into the current reward. Then we need to update the PPO agent if the time step equal to the update time step. Well, this is kind of weird. Let me just have a look at the update time step. It should be a variable at somewhere. Okay, here we go. For this line, what it says is that it will update the policy every n time step. So in other words, he do not want to update this Mario agent for every frame, but instead, in this case, it will update it every 4 frame, or yeah, I guess that's the case. Oh my god, max time step in 1 episode. So he gonna update that for every 4,000 loops. That's a lot. Why he wanna do that? Anyway, that's how it does. It's probably because if you train it with 4,000 pieces of data, then it would be more, let's say, efficient for that model to take instead of doing it 1 by 1 per frame. That will stuck your process to collect the data. I guess that's the reason. Okay, let's go on. The save model frequency defines how frequent you want this software to save your model. Well, it seems like the let me have a look at this. Okay, after we update the PPO agent, what's the next step? If continuous action space, then decay the action standard of the output action distribution. What is that? Decay action standard. Why he wanna do it? I don't know. I don't even know what the decay, the meaning of the decay here. Well, it indeed has a continuous action space. For example, for the game we play right now, it is a continuous game. Well, it's I don't know. Let me just go on. Well, maybe that's not important at all. Okay, let me go on to have a look at the PPO model or class, this other roads. For the whole model, the most important 2 parts is the select action and the update. The select action is actually the predict function. Well, it also uses with keyword here. With torch no gradient state equal to whatever, then the policy old act. Then for the update, for this function, what it does is to take those rewards and take those stuff. If it's terminated, then the discounted reward would be equal to 0. Otherwise, it will continues to calculate the reward along the time, or let's say with the time in a period of time by using this formula. The reward plus the self gamma times the reward inside of that list. Oh, sorry. Anyway, it's just a way to calculate out the reward it will get, or it gets, in a period of time instead of a single frame. This makes sense because when you play the Mario, you will lessly to say that a single action will determine how good you play, but instead you will just take a period of time to say during that time how well you play. For example, if you didn't die, if you didn't touch any animal, if you didn't get in touch with any enemy, or if you didn't fall, then you indeed play very well at that period of time. So this is how you determine the reward. Oh, you see what? I just saw the Mario passed the level 1. That's great. Well, for the pytorch, I guess the most special part for it is that for the feed function, for the same thing in the TensorFlow with a feed, a function called feed, in the pytorch, what it does is to do it manually. So you have to write all those commands to do that stuff. You have to do this step manually here, and you have to calculate out the loss manually by yourself. Okay, I guess for this model or for this repository, what he did is to use those linear function as the actor and as a critic model. If we want to reuse his code, what we would likely to do is to rewrite this sequence model. Instead of this, we will rewrite it like this one, so that we could process the raw image. Okay, let me give it a start. But I think for this game, anyway, never mind. I was just trying to say if we can have the position of the Mario and have the position of his enemy, then this would be much simpler for us to write a program to play the game. But in the reality, for example, if you wanna write a program, or if you wanna create a machine learning model to drive the car automatically, you have to deal with computer vision, because nobody will tell you those people around your car, the location of those people around your car. You have to figure it out by yourself. Okay, here we go. This is how the whole automatic car works. First, it's my assumption. First, it will take the map data. For example, this one, it will take that data and the current location of your car, so that it would know where are you right now, so that it could do a navigation, so that you won't get lost in the city or anywhere in this world. And then it will try to do a mask by using those camera around your car. Something like this, but more crazy. Instead of one car, everything else would also become a pure corner stop. Here we go, it's something like this. So everything would become a pure corner and with its label. By combine this information and the map information all together, the car would be automatically know where you should go and how to bypass those obstacles, how to bypass those people, and in the end you got an automatic driving car. Well, it's not a hard technique. The hard part is that you have to combine the software with the hardware together, while you have to make sure that no mistake would happen, otherwise people would die. Well, I just found an unfortunate thing, which is I didn't uncomment the 2 lines of code, so that our model will not save it automatically. So no matter how hard we train this model, we will lose it whenever we stop it. Okay, it seems like it's doing a pretty good job for now. I'll just stop it and try to modify it for a little bit, then uncomment this code. This is quite important. Let's see what it does. If the current episode divided by the save interval equal to 0 and the current episode greater than 0, it do the saving. Okay, we will save it when per 50 episode. Great. Let me print out the X. For now, you should know why. Sometimes we will get the 8, sometimes we will get 1 because that's the memory, or that's a list of data. But I really do not think that I want to get rid of the RGB. I think it would be okay for us to remain the RGB corners. Okay, after some modification for the inputs of the convolutional layer, and also for the I didn't modify this. Oh, and this, the RGB corner. I somehow remain the RGB instead of giving the model a gray image. We'll see how it does. For now, I'll just leave it here, and 1 hour later, I'll go back and do a check about it. Okay, I was kind of tired for now, so I'll just end this video. As long as we know that this method works, then that's enough. Even though it's not a general AI, it's not a general approach to make the machine intelligent, but it's indeed achieved one purpose, which is to use a machine to play Mario automatically. So this is today's video. I'll see you guys in the next one. Bye bye.